So now we're going to look at other forms of linear equations in Chapter 3, Section 3. So in the previous section, we looked at the form of the linear equation y equals mx plus b. And so now we're going to look at a different form, which we call y minus y1 equals m times x minus x1, where there is a point on the graph x1 and y comma y1. So let's first suppose that we have the relation y minus 4 equals 2 times x minus 5. So if, let's say, we substitute the point 5, 4 into this equation where x equals 5 and y equals 4, then what we're going to get is 4 minus 4 equals 2 times 5 minus 5, which this is 0 and this is also 0. So this is a true statement right here. So that means when we're in this form, y minus 4 equals 2 times x minus 5, the point 54 must be on that graph. So if we have this equation, y minus 4 equals 2 times x minus 5, and we distribute the 2 in, and then add 4 to both sides, we're going to get this. So first distributing the 2, we get y minus 4 equals 2x minus 10. Then adding the 4 to both sides, we're going to get y equals 2x minus 6. So now this equation, which is equivalent, is written in a different form, which we call slope-intercept form. So these are two different forms of the same equation. So there are actually three different forms of linear equations that we've gone over now. So the first is what we went over last section, and that is slope-intercept form. And that's y equals mx plus b. The reason why it's called slope-intercept is this equation will show you what the slope is and the y-intercept, where m is the slope and b is the y-intercept. The second form, point-slope form, is y minus y1 equals m times x minus x1. Now this is where there is a point on the graph x1, y1. The reason it's called point slope is this y minus y1 and x minus x1 shows a point on the graph, x1, y1, and it also displays the slope with this m term in front of that. And a third form of the linear equation is standard form, which is ax plus by equals c. Now this is where you move both variables to the same side of the equation and then you eliminate all fractions, so you get integer coefficients for a, b, and c. So for this example, we're going to have the equation y minus 5 equals negative 3 halves times x plus 1. And we're going to want to first plot the graph, then transform it into slope-intercept form, and then finally transform it into standard form with ax plus by equals c, where a, b, and c are integer coefficients. So first thing we're going to do is draw the graph. So we're going to start, by drawing our axes here and labeling them x and y. Then we're going to want to use the fact that this is point slope form, so we already know one point is going to be on the graph. Now, since it was in the form y minus y1 equals m times x minus x1, the point x1, y1 here is going to be negative 1 comma 5 because this is a plus sign, so the negatives had canceled. So we're going to go negative 1 right here and then 5 up. 1, 2, 3, 4, 5. So this point will be right here. At this point, we know it's a linear equation, and we know the slope is going to be negative 3 halves, so we can count 1, 2, 3, 1, 2. Then 1, 2, 3, 1, 2. And then we can count up 3 units. 1, 2, 3, 1, 2. And at this point, we can just connect these points. The second step we're going to want to do is transform this into slope-intercept form. So to get this into slope-intercept form, we need to write it as y equals mx plus b. So we need to get the y term by itself as well as distribute this negative 3 halves in. So before we do that, we're going to just distribute the negative 3 halves. So we're going to have y minus 5 equals negative 3 halves x minus 3 halves. At this point, we can add 5 to both sides. So we're going to have y equals negative 3 halves x, and then to add 5 to both sides, we're going to end up with a complex fraction, so it's going to be negative 3 halves plus 5, or 10 halves, which is going to be 7 halves. So this will be negative 3 halves x plus 7 halves. And so this would be the equation in slope-intercept form. At this point, we need to get it into the standard form, which is where ax plus by equals c, where ax and by are, and a, b, and c are all integers. So to do that, we need to have x and y on the same side of the equation, as well as get rid of all these fractions. So we're going to first start by getting rid of the fractions, but to do that, we need to multiply both sides of the equation by 2. So we're going to first multiply, we'll multiply the left side by 2 and get 2y. And then if we multiply this side by 2, it's going to distribute n, and we'll get negative 3x plus 7. Then we can just move the 3x over, and we'll get 3x plus 2y equals 7. And so that would be the equation written in standard form.